A very good morning to everyone. Myself, Dr. A. Kritika, Professor, Department of Physics, Nanda College of Technology. Here I am going to give a presentation on gyroscope. So the main content behind this topic is introduction, properties of gyroscope, its working principle, and finally applications. So if you see the gyroscope introduction, so this is the basic gyroscope model. It's a device for measuring or maintaining orientation based on the principles of conservation of angular momentum. So that is nothing but when external torque is not applied, the total system is conserved. That is the principle of conservation of angular momentum. This means that the gyroscope rotating element, usually a wheel or a rotor, that we can say it a disc, will resist changes to its axis of rotation. It is like a spinning top that, when spinning fast enough, will resist being knocked over or tilted. So the main properties of gyroscope are the two basic properties are rigidity and precision. So rigidity is the axis of rotation of the gyro wheel, which tends to remain in a fixed direction in space if no forces applied to it. Precision is nothing but the axis of rotation has a tendency to turn at a right angle to the direction of an applied force. The working principle of gyroscope is explained here. So this is the basic gyroscope, and the parts are we have seen the parts. That is, we have a gimbal, and then a rotor here, and then spin axis, and above that you have a gyroscope frame. So now we see the working. A large rotor that is placed on light supporting rings known as gimbals is the basic structure of the gyroscope. So because of the frictionless bearings in the gimbals, the center rotor is shielded from external torques. The axis of rotating wheel establishes the spinning axis. When rotor revolves around an axis, it has 3 degrees of rotational freedom. It retains the high-speed rotation axis of its core rotor after acquiring extraordinarily stable balance at high speeds. So the basic thing in a gyroscope is the precision. It is used to assess orientation when a gyroscope is subject to an external forces or rotations about a specific axis. Generally, we can say it as when an item revolving on an axis experiences an external torque perpendicular to the rotational axis. We have precision occurs. The basic equation in precision is nothing but it's a relation connecting the torque tau L, angular momentum, I is the moment of inertia, omega is the angular velocity, and alpha is the angular acceleration. It says that when the external torque is applied perpendicular to the axis of rotation, and therefore the perpendicular to the angular momentum, results in the rotation about an axis perpendicular to both the torque and angular momentum. This motion is said to be in precision. Finally, it can be represented as T equal to WP cross product of I, that is, WP is nothing but angular velocity of precision. So the basic types of the gyroscope are mechanical gyroscope, optical gyroscope, and gas bearing gyroscope. Finally, coming to the applications, we have some of the applications shown here. Gyro compass. It's nothing but is used in the ships. That is, while a gyro compass seeks for north, a directional gyro may not. To achieve this, it senses the rotation of the Earth's axis and then searches for true north rather than the magnetic north. So it gives the direction. And then another application is a toy. So this is the toy gyroscope. Is mainly used as an excellent instrumental aids for teaching children how gyroscope functions. And then indicator, it's a heading indicators. It commonly refers to as directional gyros, which are used in heading indicators. It's nothing but an flying instrument that pilots use to know the direction and course of their aircraft. So we have seen some of the basic things about gyroscope, how it works, and what are its types, and finally applications. Thank you.